so we can get started. I'm Jack. I'm the head of special projects at Turbine. That just means I do whatever they need me to do. So that is teaching classes on Saturday in another continent today. Bert, I'll let you introduce yourself.
I'm Bert. Everybody calls me Bert. Also a teacher at Turbine and developer at Turbine, working on these special projects and teaching the builders cohort, SVM cohort, advanced class cohort. So I'm also all around.
Oh yeah, I teach the front of the class.
Yeah, I'm W. Nice to meet you all. I did the builders cohort last semester and now joined the SVM cohort with Bert. I was here in AthensDAOx and yeah, she asked me if I could help and here I am. So excited to get into it. I'd like to share some of my experience as well and get into some anchor with you guys later.
Beautiful.
Yeah.
Alright, so we're just going to start by explaining how Solana works at the fairly high level, because you can study that for a long time and really not understand it. So we'll try and give you a brief overview. This is the words of saying basically what I'm saying. We're going to go through what is called, or parts of what is Solana, how it works, .xyz. This is, if you want to learn Solana real fast, read all of this, break it into chunks, etc. This is something that Lofton, who is a Turbine graduate who works at Helios now, he put this together 6-8 months ago, and it's the most comprehensive explanation of Solana out there. And we're going to go on a higher level of this higher level, but if you really want to get deep into it, this is the best guide. But for us, let's just jump into some of the most important parts of the Solana blockchain. So first, this is just the simple kind of diagram of how connecting with a DApp works and like what that means. So first, if you don't know what a DApp is, that just means a decentralized app. It's nothing special. They just like to make it easier to say. But these 5 steps are essentially, you have your wallet. It can be something like Phantom Wallet, Backpack, etc., or maybe it's a custodial wallet. For example, like if you just got that NFT through your email, that would be a custodial. That's custodial, right?
Yeah.
I always mix it up. Custodial, but basically you will do this spot.
Besides the Phantom wallet, there's also Soulflare, which is a little more specialized for Solana stuff. Phantom is going a little bit broader. They are picking up more chains, and some people say that if you have a lot of multiple different teams for the same application to develop, then it's not going to work out really good.
You can have a non-custodial wallet on the Phantom also.
Mm-hmm.
You can connect to that.
Yes.
That's hardware.
Yeah, hardware. So basically the steps now do this sort of live. This first one, you will just connect your wallet. You will select the wallet here. Boom. Great. I don't know why it says I have to. Oh, that's because all of my soul is saved. But so this is step 1. You connect, and then within the app, if I want to do something, the app will actually build transactions. So let me just buy some more soul.
You should also know about the wallets is that there's a little bit of a separate environment for your private keys. So your private keys, which is used to sign the transactions, are never getting out of that environment. That's why you see the DApp creates the transaction, then it sends to the wallet to sign it, and then after that it gets to your central address.
Cool. So yeah. So what's happening is I'm connected with this wallet. And then what happens is now Jupiter is building the transactions that I will send. So that's going on here. This is happening in the Jupiter app. And then when I actually click swap, what's going to happen here is it sends the transaction to my wallet to this extension here. Where'd you go? Navigating on Macs. Jesus. Okay.
Yes.
So now we're on step 3, so it's being sent here, And then on step 4, I'll click this confirm here, and hopefully this doesn't type out. Then finally, after I did that, I signed it, send it back into the app, and then from the app, it sends it to the RPC, which is basically your connection point to the Solana blockchain. So now you'll see I may have or may not have successfully swapped this. Oh, I did. It says insufficient USDC. So I can see that
Solana is dropping today, maybe you should swap it back.
it's all long-term holds. But you can see here a few seconds ago, this was actually a transaction that got sent to the blockchain. And I don't know, let's see if the next slide goes into what transaction is. Okay. Got it, okay. This is talking about failed transactions, which, so, if you think, it's a little confusing because when you think something's failed, you think it shouldn't actually like charge you or anything, but you actually will be charged because you are sending a transaction to the blockchain and it tries to make it happen and then it throws an error. But transaction fees are just fees for running compute. So even though you did something that didn't execute, you're paying for compute essentially. And whether that compute succeeds or fails, you still asked something to happen and you have to pay for that thing to happen. So an example of
Oh yeah, maybe a funny anecdote. Last weekend with you might have known about the Trump and Melania token. So at some point Solana was pretty unusable, and that's because everybody was competing for those compute units, or that's what sent the compute units up.
Mhm.
So you said you were, if someone said about arbitrage bots, right? You?
Yeah.
So I was also running my own bots and doing my own stuff, and you could see my transactions were failing, but you were still paying a shit ton of SOL, or some my language, or you were still paying a lot of
So
SOL.
those slippers.
Actual the transaction fees were going up to like 0.1 SOL, and that's so even though your transaction fails, you still pay that amount, and people got blown up by that. So.
Where's that going?
To
Burned.
the validators.
Burned.
It's just
well, yeah, some of it's burned, some
You're
of it's
supposed to
valid.
bribe the validators with
Yes.
more.
yeah,
But
exactly.
then that's.
But then it's
No,
the cycle
it's
of
a
everybody
bit of
bribing a
topic,
little bit
yeah.
more.
There's a little extra to add to it. I read that somewhere that 95% of the failed transactions on Solana are failed because the slippage was not reached. So and all the transactions are coming from 0.1% of the wallets, which are probably the bot wallets that are trying to game the system.
And is there an explanation why they would include so many failed transactions? Like, why validators can't simulate locally passing successful transactions and get rid of the one that we failed because of
Well, how do
simulation?
you know that it failed? You have to run it, right?
You have to.
You have to run it to know that it
You
fails.
have to run it, but I think they showed that most of the time validators spend not so much time on actual transaction processing, but it's a lot of verifications and stuff around. So maybe they have some time left, some threads that could run on the verification, the local simulation.
So that is done on your own local. I mean, sometimes on your own machine. I can actually show you on like Phantom. Let me just pull up something and try and
Nothing.
forcibly fail myself. But you can. It won't work for everything, but there are transactions where on like Phantom it'll be like, hey, this is good. If you send this, it's going to fail.
Yeah.
Some people just keep pressing send, but there really isn't like. And to go on to what you were saying, where validators aren't actually parsing things. So the way it actually works is you have a leader that's actually like the one validator that's, oh, I'm executing it, and then everybody else is going and like replaying and validating it. So, and that's constantly switching around. So it's like everybody runs the transaction at some point, but there's someone who's like does it first and actually like makes it happen, and then everything else is kind of a sanity check.
How do you validate?
Sorry, what was that?
What is a validation? What does a validation look like? It's proof of stake.
Yeah, you can take that.
That's a little So there are two ways of for Solana. There's one is a proof of time that's ticking every second, and that gives the ticks and the transactions getting mixed in. And the other one is the proof of stake. So like Jack said, he's staking his soul, so he's delegating his voting power to a validator to vote on specific blocks. And these two systems are coming together. And that's actually just really a small part of the whole picture. But we'd like to just keep it on a high level for now, not go
But
too
how
deep.
does this compare to proof of work cryptocurrency?
Well, proof of work is a lot of calculation, a lot of hashing. It takes a lot of time to do it. When you are using proof of stake, you are basically just giving power to the validator and actually lifting him up to be able to vote on specific blocks. And that's how the blocks are getting verified. So if a lot of people trust the validator that he's right, they're gonna stake a lot of soul for him. He gets higher in the chain, becomes a leader a lot more times than the rest of the validators because they're just stake weight also. So the more stake you have, the more power you have to get to the leader position.
But compared to paying transaction, is it better or worse?
Much faster and less
The faster for sure.
and the less
And less energy efficient.
less
Less
energy.
energy consuming.
Exactly. That's it.
Tiny question. To your knowledge, I've heard that Phantom Wallet includes priority feeds kind of mixed in, so therefore it's more like a Solana transaction versus Sulfur. Is that, to your knowledge, is that the case, or have you heard that? Or
Phantom? I'm not really sure.
I'm just curious because I heard it. I was like, really? Okay.
Well, I just want to go back to the simulation for a second, because there is a way. So there's a way to check transactions before you actually execute them. It's called a pre-fight check. But that still, it happens that you create a transaction and you send to the validator to check if it's gonna be valid or not. So the validator can simulate it and then send it back to you that okay, that's gonna be a good transaction. You can send the transaction live.
Yeah.
But it's a lot of resource to make these pre-fight checks. So most of the traders, and of course time. So most of the traders are just skipping that part and trying to make their own transactions and push to the chain and it fails. So that's why a lot of failed transactions do reach.
I think the most transparent service is Juke because they show you the whole network flow and the breakdown of the fees, and you have the ability to choose a different flow or chain and maybe make the same transaction with less or more fees. Or you can, play the Wild West and, because it says, you want the cheap one or the reliable one. But it shows you exactly the route. It has a preview, so you don't gamble so much.
Yeah, trying to find a more interesting route. This is
Jupyter has a lot of really nice functions that you can go really
But speaking about transparency more,
how you set it up.
I don't think you're gonna get a problem switching from USDC, let's say, to Sol. But if you switch from USDC to an unknown coin, maybe it's you need a service like Zoop or to feel like that your transaction will not fail and will complete.
I guess Jupyter might build some extra check to make sure that what they are the transaction are go through. I'm not really sure what they do.
I like the recommendation engine anyway, that it says, it doesn't tell you only what you have to pay, but it gives you additional options.
Those
Phantom, it just says go with it or not go.
Well, you still have the possibility to just set some things in Phantom to make it change it up a little bit. But Jupyter is really the top on these on top of this game. So
Oh, Lex, okay. Yeah, it looks like, to answer your question, they do apply priority fees if they are not being applied by, if the DApp doesn't already do it for you. It seems that they do a, catch-all kind of way of doing it. DApp should do it for you because, whatever your specific thing is, you should write hyper-specific stuff or priority fees for how your app is going to be used, and Phantom's not going to know your system how you know your system, so they're just going to do a kind of catch-all based on what the market looks like right now, or it's the priority fee market, not just the market, but everything's market. Cool. All right, on to the next slide. Beautiful. All right. Do you want to take this one, or do you want me to talk about the actual validator or
You can go for it.
transaction processing.
I can join.
All right, sweet. So this is the transaction processing unit. So when you actually have a transaction come into your validator, this is what's going to happen. So these validators over here would be your what are they called when you're sending it? The ones that like I send it to this validator, then I send it to that one, and finally gets to the leader.
What are those validators? Yeah, they are just some validators.
They're
not
just
the leaders at
they're
that moment.
they're not the leaders. So like when I send, so let's pretend right now that the leader is in Bangkok. We're not in Bangkok. So what would happen is when I send my transaction to the RPC, it'll send it to a validator in I don't know how geography works. So I'm just gonna say countries and hopefully it works to like Hungary, and then somewhere east of Hungary, and then further east, so on and so forth. And it'll jump from validator to validator to validator until it hits the leader. And then the leader is the one who will actually execute this whole transaction processing unit. So the first stage, the fetch stage, just like, give me all of your transactions. And I'll just kind of get them in and just basically build up a list of 10,000 or hundreds of thousands or whatever transactions. You have a question?
Yes. I just wanted to ask, because you are referring to a leader validator, does it change on every epoch or something like that?
Yes.
So it's more the same.
Hypothetically, every block it changes, but
Okay.
sometimes you'll have like 10 blocks in a row where you are the leader, etc. But like every 400 milliseconds, the leader could change.
But okay, I guess it uses some random engine, right? But we know that those engines are not purely random. Doesn't this pose any issues, like safety ones? You can approximate who will be the leader and you get some type of advantage.
So who the next leader is all dependent on stake. So if I have more stake with me, I'm more likely to be the next leader.
Okay.
So that's kind of how it does, and it's basically just like, if I have 2% of the stake, I have a 2% chance that I'm going to be the leader next time. And like, hypothetically, yes, there could be problems, but for those problems to arise, you would need to to actually take over the Solana network, you would need 66 plus 1% of the validators to be like bugged or have a problem or just like have all the stake in basically one validator. So that's why it's good to distribute stake amongst various clients. So like, especially now, is Firedancer on mainnet or not yet?
It's Frankendancer.
Okay, it's still Frankendancer, but that's like a big change is everything has been in Rust, and now there's Firedancer, which is going to be doing essentially the same things but in C, and so this is a huge differentiation, because if there's like some huge vulnerability that's found in Rust, and if every validator was running that, it's just like, okay, the chains were fucked. But if the diversity, and then even within those clients, like there's Onzo, that used to be Solana Labs, that's like the main one, but people fork that and make their own validators and change the code a little bit. So if there's like a bug in the Onzo code, as long as there are some validators that don't have that same bug, you can still operate the network.
Just a little bit for the leaders. There's actually a leader schedule set up every start of the epoch. That means for a few days you know exactly who's going to be the next leader in the line. But the reason why it's actually how do you say that, economically unfeasible to attack those validators, because the amount of transactions that are getting processed is like, the network speed is going to be gigabits, and the machine going to be really, really strong. So there are some blockades to actually use it up. But at the same time, there are some people who use this schedule to send the transactions directly to the leader. So it doesn't have to pass through all the rest of the validators to get to the leader.
Alright, cool. So after the fetch, which is just give me all of the transactions that want to be processed, the leader will take those transactions and go through and just make sure, hey, are all the signatures that need to be here, are they here, and are they valid? And if they are, then you are sent into the banking stage, and if not, then you are a failed transaction and you get yeeted, or this is one of the places that you can fail. The banking stage, this is where things are actually executed. So you can see these kind of little dots, these are just supposed to be different transactions happening that they can be executed in parallel. That's why we have a bunch of these. That's a huge advantage of the SVM over EVM, etc., is that you have parallel processing. So for example, if I'm running the Jupyter smart contract, what it can do is actually load that contract into memory, but apply it to 4 transactions at a time. You have 6 cores running. But
There are 4 banking threads,
Yeah.
so yeah, you can load it 4 times.
so you can have it operating on 4 transactions instead of 1 at the same time. Within the banking stage, you have your proof of history up here. This is basically your clock, but it's not like your normal wall clock. Come on, word it faster. You're supposed to have clocks. It's like a whole thing. All right. Well, it's not a clock. It's actually just basically the way proof of history works is you're constantly hashing the last transaction, and the idea is you can only do this so fast, and if you want to trick it and get something fake in, you would have to be operating twice as fast as any other CPU on the market, which is just feasibly impossible because every Solana validator is going to be using the top of the line hardware, and there's no CPU out there that is twice as good as all of the other ones, and if there were, everyone would be using it. So that's kind of the idea is you're constantly going to have the best thing working, and everybody is working as fast as possible to do the exact same thing. And as long as I have the same value that you have, I know that we are in lockstep, but the idea here is I can't trust any external source to like get time because they could be lying to me. So I need to be able to internally be able to know what time it is on the blockchain, and every validator can do this independently. So that gives you kind of like your place in time. This is like your block hash. And then if your transaction succeeds, you're going to have some change of state. And so down here, this is the bank is where you're actually writing to the accounts database, and you're just saying, hey, Solana was moved from here to here, or USD was moved from here to here. And that's just kind of the entry chain. Once that happens, the broadcast stage is kind of like the opposite of the fetch stage. This is where it's like you're going back out and you're yelling to like 5 validators, and then each of those validators send it to another 5 validators, so now it's like 30 have it, and so on and so forth until it perpetuates to the rest of the network, and that's how everybody stays in sync. And then I forget what's the turbine tree. Now turbine just means turbine to me.
Well, yeah, that's when you are actually, that's pretty much go to the stage after that when you are sharing the stuff between validators to verify everything that happens. So there are multiple layers of networking between the validators. So when the first transaction is a validator, before actually it gets verified, it's going to get shredded and sent away to the rest of the validators. And on the end, again, it's going to be a little bit of a sharing of the information.
So you both have proof of stake and proof of why?
Yes, this is proof of history, which is not to be confused with proof of work. But yeah, that's
It's on the left, it's the proof of stake, and then in the middle is
No, it's actually it's so for the proof of history is that it's constantly ticking. So that verifies that you can't go, there's always a time limit that you can put stuff in, but the stake is to give the power to the validators to actually vote on the block. That's a good block. They're working in London or something like that.
okay. So this is going more into the here would be a validator or your lead validator. This would be a validator that is not currently the leader. This is what they do. So you have the shreds that were sent out by the leader. You take them in here, and then you verify it. I don't remember what this does, but the big thing is really the replay stage where it's like, hey, okay, you said this transaction happened. I'm going to rerun this transaction and verify that it actually is what you said it is. And if it does, then you're like, yep. And if it's not, then hypothetically you would get slashed, but we don't have slashing yet and may never implement slashing at this point. But that's kind of like the idea is like you have your lead validator who comes in, does the actual transaction processing, and then sends it out to the rest of the network, and then the rest of the network will take these shreds, so you don't have to do the whole. You don't have to send all the data. It's erasure coded, so you can reconstruct the data from just a part of the data. I don't really understand how that works, but it's really cool. So if you want to learn about erasure coding, go for it. But basically, I can take a transaction that was executed and I make sure that what you said was going to happen actually happens. And then if it did, then I'm like, yep, you did a good job, validator. And then that validator is allowed to get their staking rewards.
What retransmit stages is actually, that's happening again, what you see here. So the retransmit stage says that all the validators are communicating with each other constantly on a really, really high speed, and then bombarding each other with all the shreds. So that's quite possible that some of the validators receive the same shreds like 10 times, but that helps in saving time instead of waiting 15 minutes to get the block validated and then verified and everything like that. That retransmit stage happens before actually the stuff is getting verified. So unverified blocks are getting shredded up and distributed between the validators. So everybody can almost at the same time replay all those shreds to validate. So it's really, really fast.
Sweet. Is that the end? Okay, so this is the recap of this class, but it's just we're just gonna keep going and going because I don't think new people are gonna come in. Basically, when you are interacting with the DApp, you connect to the wallet, your transaction is created, and it gets sent to your Phantom wallet or Soulflare or Backpack or whoever. I guess this is where I should show that I know how the front end works and stuff. So the reason why you have an extension and why it's here is because in a Chrome or whatever extension, whatever executes and all the data in there is not accessible to your app. So what I can do is I can serialize a Solana transaction and send it somewhere else, and then it can be signed and sent back to me. So basically it's all your own little trusted execution environment because I trust that my computer is working well, and I trust that Phantom is not trying to steal my private key. And I definitely don't want to share my private key with just every DApp that I interact with because then 100% one of them is going to steal all my money. So this allows me to keep my private key from ever being seen by the app, but still interact with it. So that's where the signing comes in here. And then the broadcasting is from the app actually sending it to the chain. And then now in the chain here, we have whoever our lead validator, they come in, they check the transaction. Consensus is basically when you have all of your validators who have gone and replayed it, they all vote to say yes, this is valid, or no, this is not valid, and if 66 plus 1 say yes, this is valid, then the transaction will be added to the block, and then eventually that block is committed and saved to the chain, and it cannot be changed after that fact. And then finalization is once there's you have the 66, or you get to a point where it's hey, it looks like this is probably going to succeed, and then you start producing the block, and then when it's finalized, you're okay, we actually know this was successful. That's kind of if you think American here, but a lot of people like to pay attention to the elections because they're crazy, but it's oh, you see the projections going for Kamala, then it's changing to Trump, and blah, 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 but then it's there's a point where they haven't read all of the votes, but they can call it for Donald Trump this time, because they're okay, feasibly, even if everybody else says no, we still have enough people and it's trending such that we know it will succeed. Execution is just transaction actually being executed in the valid or the lead validator. The state update is when you're actually just committing the data change, whatever it is, money moving from here to here to here, data, etc. That's the state update. And then finally, the notification is just a response from the chain being yep, your thing went through. Good job. Cool. Oh, this is...
How much through?
I got it. Not well, actually.
But that's actually just, yeah.
Literally right here.
So the Solana how it works is going to give you a broader view of what we just talked about in this a few minutes.
No, there's no like present.
Let's do this.
Okay, beautiful. Alright, okay. This is a very big overview of like the whole thing, and
There's so fat. Oh, it closed it hard by. No, don't do that. Over here.
Solana, how it works, .xyz. But basically, when you're going through Solana, how it works, you'll see on kind of all of these little, there's this diagram here, this like 6-part thing. This is kind of like the continual loop, and so as you're going through this article, you can see like where in this, like, in these 6 stages, where am I? So these are like the 6 stages of Solana. So, 2 of these, yeah, we went over this one and this one, so it's like you connect to, can you please go away? Like, let me be, what is it, F11?
John,
We'll give it back to you.
There's definitely a way to do it, because I do it accidentally all the time. Alright, I'm going to stop doing that before I break something. But basically, okay, the steps that we sort of skipped were, this that will bring me up, is from connecting to the app, then we send it to the RPC here, and there's going to be a bazillion RPCs around the globe. This is just like, you're going to send it to whichever one's the closest. And then from these RPCs, they will send it to these different validators who will have different levels of stake. Please go away, Mr. Open. No? Okay. But basically, some of them, they will have different state, and then one of them will be the leader. So this one is this purple one, and 3% of the stake. Within this leader, we see everything happening that we talked about before. And then when we take the shreds, this is the turbine part, sending it out to the different nodes, it's basically, and you can see the different colors here, the black, purple, and gray. These would be different shreds, so you can see there being, different shreds are being sent to different validators, and then like within here they would send to each other again and then be able to reconstruct the transaction, validate it and everything. This was also, we went through, it's just condensed here, but it's, these are the people actually replaying it, making sure it works, and if all that happens, you actually create the block. And then if your transaction gets added to the block, then you go back and tell your user, congratulations, your transaction went through. And then the user makes another transaction, and the circle continues.
So, this loop, when a transaction fails, which part is failed?
You can fail in a few different spots. So if your signatures are wrong, it won't pass in the verify phase. But if the signatures are correct and what's actually, like the actual code doesn't work, you try to divide by 0 or subtract or make a unsigned into negative, whatever it is, that would fail in this banking stage here, because this is when the transaction is actually being executed. Are there other places it can fail, or is it really?
Yeah, for example, if you want to send some SOL and you say, I want to send 2 and there's only 1, then probably banking is going to fail because you don't have enough SOL. So even if you send it, the signature is valid, it's not going to pass. So there are multiple places that you can fail. But I would say if, what I was talking about, the pre-flight check, so you can actually send the transaction for simulation to the validator, that would be somewhere here, so between the RPC, we have somewhere here, so around the RPC and the validators, and if it fails there, it's just a simulation of what things would happen.
Let's see if I can do that right now, or no. I want to send.
RPC.
Very procedural.
Come on.
Any forks?
I'm sorry.
Any forks in the blockchain?
Forks. There are, but that's why validators are working on blocks. So if how can I say it, the blast. So they start to produce some blocks, and those actually could become forks. But if those blocks are not getting approved by the rest of the validators, then it's gonna just fail.
I think the interesting with there has never been forks that have been optimistically validated. There has never been in the history of Solana blocks that, forks, minority forks that receive more than 2/3 of the validated blocks. And like many blockchain where you have reorganizations and stuff like this, it doesn't have basically never happened on Solana, but it's not excluded. That's why the finality that I can get 32 blocks.
If there is a theorem, like theoretical theorem for two-phase,
It's there. I think there is some work on proving the execution and stuff like that. But for now, it's mostly practical. I think there's no explanation why it's 32 blocks before finality.
at least the theoretical one has to do with how much power is on the one entity in the thing, like in the pool. Like you don't have too much power. No one has too much power.
But even if formally there is a lot of power and he votes on it, it's still just a small percentage of all the validators.
Exactly. Yeah.
It would not pass. So I would say there happens a little bit of voting. So when the validator starts to build a specific block because he thinks that that's valid, it's kind of going on a separate fork, but it's pretty quick cut down because none of the other validators are going to vote on it. So the forks are just really short between just a few processing of transactions, trying to process transactions.
In Ethereum, we have the concept of MEV, where we can deal with the leader. Is this possible?
Oh yeah.
Solana for
Unfortunately, yes.
Well,
Unfortunately.
maybe unfortunately for you.
Yeah.
Well, the thing is, a lot of people use it for not the right purposes. So it does have a place for in blockchain to extract a lot of value, so maximum extracted value, of course. But there are also sandwich attacks. So
And for this occasion, we have flashbots where I can send to a private RPC, and it can wait until it becomes leader, and then it will execute. Is it possible to get protected like this?
that's the solution.
Is there something like this in Solana?
Honestly, the biggest protection is just the blockchains are faster, so you can't do flash loans and stuff like that. But obviously, there's still arbitrage within 400 milliseconds, and that's where it's like there are L2s on Solana where you can get it. Like that'll be on a private RPC network. There's like ephemeral rollups by I can't remember the name, but I can remember the guy. Magic Block, yes, and they're operating at 25 millisecond block times, and so that's like even harder to find MEV at that point. But that's like even with like Jito,
I think Jito is exactly Flashbots.
yes,
It's flat. It's exactly the same. They have parallel mempool or they share transaction offside, build blocks on their own, and you can have you can send bundles on Jito a full block of what you want to insert, and if you pay enough money
For a small fee.
they will insert your transaction however you like.
Okay.
it's basically you instead of getting MEV, you pay a fee. So instead of the bot getting the money, Jito
You
gets
pay 10% instead of being drained.
exactly.
It's okay. Fair enough.
Cool. Let's see what the next slide is.
Yes.
It's my favorite slide. Yes, our 5-week boot camps are way better than others' 3-week boot camps.
So we have a
Let's
lot
take
of
8.
we have multiple offerings also for builders cohort. That's dealing with the basics of Solana and how to interact with Solana through TypeScript, and also how to build a little actually smart contracts with Anchor.
Yeah, so this is 4. We actually have 6. I guess I should probably. This is my job. I should fix this. We're actually having to fix it. I don't know if we have any applications yet, but there are. Oh, I guess you can just apply to the advanced course and then there's a drop down. Yeah. Okay, so we're not offering. I didn't make a mistake, but we have. So this is actually 4 or 5 courses here because this is 2 that you can apply to for both his courses. This is my course. This is Andre's course, but y'all are, or at least you are involved in it. And then this is, I guess, Jeff's course. This one is, I should have did that. I should have did that. But
Jeff's also going to talk about that one later today.
yeah, Jeff is the CEO of Turbine, one of the founders. He's a character for sure. But this is one of the cool new things. We're partnered with Anagram and Solana Foundation and working to just bring research to Solana because most universities don't support blockchain research, so we kind of have to do it in our own, like, privately, but it's all public. Like, we post our findings and
So
such
these
and
are
such.
all public offerings, free of charge. You can join, of course. And the reason why we put the slide there is it's a fast-paced course, so we are pushing it through within a short time. But we get familiar a little bit with TypeScript, the Solana client, how to interact with their chain, and like I said, actually we getting a smart contract.
And when do this begin?
Every
Yeah.
quarter.
Every quarter, yeah.
So the next one will start
March.
March-ish. Yeah.
And so the fast-pacedness is like it's 3 lectures a week, and you have 2 time slots, so either for the US times in the morning or afternoon. And it's basically required that you come to every lecture. Of course, if you, I don't know, flying to Athens, you can probably miss one, but yeah. And then also, I think a good highlight is that you start off with, like the first week, I remember we minted an NFT, did our own token creation, and then like some MetaFlex stuff, so that was quite interesting. And then we went into AMMs, so automated market making with swaps, and then vault program, escrow, so it's action packed. And then a big part of the builders cohort is that in the last part you build your own project, so it's called a capstone. It also helps you with developing your GitHub, so you can get some, for people that are new to coding, for me at least, it was great.
And I think
You did
for
market-
those,
Market making in the second week?
third week, but yeah.
So, well, no, it's just setting up a swap pool. And then, right? The market maker.
Yeah,
Yeah.
yeah, just the basic liquidity people will bring in.
Yeah.
Yeah, it is. It's pretty early on that you're like,
Yeah.
oh shit, we're literally building a market.
So we did it in week 5, but yeah.
I don't know. I did this a year ago. But one thing to note, I'm pretty sure if you were at the Marshmallow presentation or how to win a hackathon, I believe that Turbine, if Turbine were a country, it would have one more hackathon, or like for the Solana / now Coliseum hackathons, we have more wins than any country. So this is like, if that's you're interested, you can come in. I've won technically to public people, I'm the winningest person of Coliseum hackathons, but if you know Alpha, there's actually somebody who has won more than me under different names, but he's Anon now and he didn't used to be. But
Do you do any product discovery or design mentorship?
design and that stuff, I would actually say Dean's List, that's kind of their vibe. Like that's where our handoff is between like the two of us. We're very technical devs. They have a lot more like, if you're talking like website design and stuff, but like actual
No,
like
I mean
more-
product discovery, like what are we building and how do we validate it before we even touch the keyboard?
Okay, yes, we definitely.
Which is what I do basically.
Yeah, we do at like not a super rigorous level, but we do kind of introduce the principles of like, okay, start with like a user story and then iterate and like, don't just be like, oh, this is the thing I'm gonna make. It's like, okay, like why? Like why are you gonna make
Yeah,
this?
exactly. Like the guy from Marshmallow, right? I heard he used that kind of design thinking methodology, which
Yes.
is iterate, loop, and guys
Yeah, for
validate
sure.
with the user, not with yourself.
Yeah.
Because when you're gonna build it in the end, maybe no one wants it. And
Yeah, so we definitely do that because it's like you'll come in, you'll put in your like, this is what I think I want to do for my capstone, and then there'll be a class where you kind of like go through and the teachers are like, okay, and then if some people have similar ones, it's like, hey, you guys might want to work together, and then it's like, oh, next week you need to submit like your system design architecture, and then kind of not like defend it, but I guess kind of defend
Yeah, you
the
gotta
logic
present-
behind it and pitch it and go through that iteration and get that feedback.
You also have the demo day where you pitch it basically, so you make it like 2-3 minute pitch deck, and yeah, I did it like I think 2 months ago. It was a ton of fun, so yeah.
And the good thing is that a lot of our students are going to hackathons, and we have a lot of winners. I don't know the exact numbers right now.
It's like
There were a
50
lot of,
right now.
There were a lot of students from Turbine that actually won.
Radar, so the last one, Radar, there were 37 prizes, we won 8 of them. Right under
Should be
25%, I think.
Should be 4 hackathons with each cohort. But the
Yeah, I've been telling Nate
We can
this.
do that too.
What is the place for an Ethereum developer that wants to learn Solana? What course should I follow?
Are you trying, do you want to learn it like to write software, or do you just want to learn it to?
No, I want to build software in Solana. Want to learn.
Definitely builder's cohort.
Builders cohort.
For sure. Like I'd been in Solana for 2 years before I took the builder's cohort, and I would say I don't think I understood Solana until after I took it. Like I thought I did, but like I didn't. Well, actually, no, I think I did. Like now I definitely do. Like I was winning hackathons with actually understanding the underlying technology. I was just making businesses because I know how to make businesses, but now it's like, oh, I actually understand how Solana works as well, so I can make a business that isn't a security flaw.
Yes, exactly like this.
So yeah, I would say builders and just getting in the Turbine community is like, it's 25, well, might even be more now, but 25% of active developers in Solana are part of the have taken a Turbine class and are part of the Turbine community. So it's a very good entrance into the whole space. And for reference, Turbine's only been on Solana for like a year and a half, I think.
Exactly.
2 years? Okay,
a
a
bit longer.
little bit longer. But they started on Cosm Wasm and then like went into Sui and then realized Solana's the best blockchain, and now they're pretty much pure Solana. But it's like we haven't been here for, well, I guess actually 2 years, and Solana time is eternity, but a lot of, like I wouldn't, well, this is one of my KPIs, so like I want that number to be 33 to 50% by the end of this year. And it very easily could be. And it's just like, the idea of here is like education continuum. There's probably a slide that's going to say that at some point, if I know Jeff. That's just like the idea of whether you're working or not working, and like I've taken Turbine classes where I was working at other protocols, and they're like, go, definitely take 20 hours a week to do this because it's going to make you a better developer. And there's just like, the community there is great, and if we have somebody who's an expert, like working at a place, like for example, I'm with my front-end cohort, the last 2.5 weeks of the 4-week course, I just have guests coming in, and they're all like, or at least half of them are Turbine grads that are just like working at protocols now, and they're the expert in Solana on this thing, and it's just like, oh yeah, you want to come in and talk about this? And they're like, yeah, of course, because I had someone else do the same thing for me when I was in the builders cohort. And so it's kind of just perpetuating that whole thing. It's just like, the industry's constantly evolving, so if you want to stay up to date, you gotta basically continually re-educate yourself, and that's what we're here to do.
And also just to add a little bit, you can start with the builders cohort. That's gonna teach you, or we're gonna teach you the basic stuff. You know, like I said. The funny thing is that in the last 2 cohorts, we had like 300 applicants for both. So we are getting a lot of requests. But if you do the builders cohort and you think that, or you feel that it's not enough to build, that's something what you want to be able to do, that's something what you want to do. We have the advanced cohorts, for example, the Rust and the native Rust, writing smart contracts in native Rust instead of using Anchor framework, for example. And also the SVM class, which is built around the SVM API, and how can you use it and how can you build your own rollup. So in the last cohort, we actually built a really simple rollup with the new SVM API in 2 weeks' time. It wasn't optimistic, so it's not zk and it's not fully fledged. It's a single application rollup, but it does give you the idea how to build a rollup. And there were people actually picked that up, and they developed Backchain, which is a project that are using the SVM to show what you can do with the SVM.
Or if you're more product, then you can take my class, which is like front end / full stack. So it's like, okay, you have your Anchor contract. Let's make it something that you can actually ship to users and just go with it. So that's this is the first time that I'm teaching it right now, and then I'm gonna have to completely rewrite the curriculum because we're moving from Solana Web3.js to 2.0, which is basically they were like, yes, decentralization. Let's remove a lot of things and then make it so that everybody else has to make libraries that can actually interact with this, which has led to none of the wallets supporting it. So now that's something that Jacob's going to be like, who's the head of DevRel Solana Foundation. There's like 5 to 10 of us front-end engineers on Solana, and he's like, hey guys, can you like fix this for us? And we're all like, dude, we all have at least 2 jobs. But hopefully it'll get better. And I mean, it'll eventually be an improvement, because just there's a lot of glass chewing. If you haven't heard that phrase yet, you'll hear it a lot. Because you're doing stuff people have never done before. And that's always fun, but there's, I mean, at least if you're me, there's a lot of desk slamming and
Sometimes it's challenging.
verbal abuse of Claude and
When Anchor stops working.
Yeah, of course.
So a funny thing actually we just showed they showed the Solana how it works document quite a bit. And so to get into the SVM cohort, so that advanced cohort, you actually have to go through the document and see what part you want to work on and go into the Agave client, so the main validator from Solana apps, and see where you can improve on it. So yeah, I think if you want to get more into that, go through the document and basically prepares you to sign up for the SVM course as well.
Yeah, so the SVM course is really broad, so we are
Yeah.
talking about the runtime. We are going through the code, looking at optimization possibilities. And based on that, you can understand what do you need to actually run the SVM, and you can build your own SVM with the API.
Interesting. All of them.
You should join.
I'm just
If you're-
checking on the
What?
messages about lunch. I know we're all going to care about that. So it's
I didn't even know
seeing
what-
if they will bring the bags to us or we have to go back to get them.
That would be.
Yeah, but what about this
That's-
moonwalk? What
Okay.
is that about?
Okay, so Moonwalk. Okay, so the actual thing that they're going to do, if I know what it is, or no, I should explain what Moonwalk is first. Okay, so Moonwalk is basically, if I remember how it works, is like, imagine the 20 or so of us that are in here, we all put 100 USDC into a vault. We each do that, and we're all gonna walk 10,000 steps every day this week. And then if you do it only the people who actually follow through with that get to take back from the vault. So if we all end up doing it, we all get our money back. But if Berg decides on Sunday he'd rather just sit around, then he's only gonna get none or 6/7 of what he put in or something like that, and then everybody else will profit more, so it's kind of like a financial incentivization to be fit.
Yeah, because none of us I don't think all of us are like the gym type Monday.
Well, okay, since the new year I put on like 20 pounds, but I was very fit in 2024.
Maybe, maybe that was.
I was like that. Cool.
Yeah. Any questions for?
To not have my favorite. Okay, there is one diagram I want to go through on Solana how it works. I do this all the time. Where are we? Yeah. Okay. No. Same thing.
Go to the PDF.
Yep.
Before the courses start, do you have any onboarding documents or reading papers if we visit the website, let's say? Like, let's say about the actual framework or whatever, or what to do before to join the first class, or have to wait until the next?
Well, we prefer if somebody takes a self-initiative and look at, like, for example, if you want to know from Anchor, you can check out the documentation and catch up on it a little bit. But there is also another course provided by someone else, the Rise In, that's actually an even simpler course to prepare you to be able to join our builder cohort. So if you finish the Rise In,
Okay.
then
Perfect.
you should be able to pretty much start our build code.
And also we're gonna get into Anchor today, so that might be good to join. And also
Okay.
to join the builders cohort, they have you do a prerequisite, and it's first in TypeScript and then it's in Rust, right?
Yeah.
Oh, it's no Anchor in there. Then.
Yeah.
No, but yeah, it's
The prereq is just simple
Yeah,
operation that
it's-
you know what TypeScript is and you know how to send a transaction.
setting up a wallet on your machine.
But all of that can be learned in the Ryzen.
Yeah.
Course.
And those are taught by Turbine. Not so it's like usually like the TA of the upcoming cohort is like the one who teaches it. So it's one of the teachers that's going to be teaching you during it is giving you like the intro course here. But yeah, this is my favorite thing to explain. This is a transaction on Solana, and they're actually really simple. We're going to start from this way up. So first thing you need is your program ID. This is just what am I going to interact with. So that could be Jito, that could just be the basic Solana token program or whatever. It's just like, hey, I want to talk to this contract. And then the second thing, these are all the accounts. So it's like, for example, if we just have a simple transfer, we want to go to the system program transfer, and I have my account and then the account that I want to send it to. And then you also have to pass the system program account because that's the actual program you're interacting with. So accounts on Solana, they can either be programs and they're executable, or they just hold data. So you have to say like, okay, this program and then these two things of data, that's what I want to interact with. And so these would all be public keys. These are 32 byte public keys. And then data for the program is everything else that can't be represented by a public key. So if it's a transfer, this would just be like 1 times 10 to the 9, which would be 1 full Solana. And it's just like, hey, I want to send 1 Solana to Berg. So it'd be like, okay, system program.
He never does that.
Never. It'd be like, okay, I want to interact with the system program, and then Berg in my wallet, and then 1,000. And that's 0.000001 Sol. That's more likely. So those are like, this is the information, and then you need your recent block hash. So this is, remember that proof of history thing, that thing that's always ticking? This is basically like, hey, when I looked at the blockchain to make this is what the time was. This is what the hash was. And so this basically gives you a point in time for reference. By default, transactions will fail 30 seconds after they are, 30 seconds after that block hash, they will fail because I don't want to send a transaction to the blockchain to buy this thing, and then 3 days later it goes through and the price of it is a quarter of what it was that I paid for it, then it's like, I don't want this, so you want things to eventually expire. And then here, so as you can see, after talking about just one instruction, you can actually have multiple instructions within one transaction. So it could be like, okay, I want to send some money to Berg, a little more to Jeff, and then drain W's wallet, all in one. And then here, this is like the superset of all of the accounts. So every account that would be in here is here once, and this is just used by the validator to be like, okay, before I even go and look into the instructions, what accounts do I need to load into memory to actually execute this? These headers over here are basically just sanity checks. Good question?
Yeah, I just wanted to ask are there any types of transactions that expire faster? Because I was considering the case, for example, someone places a buy order for something. So it has to exactly match the price and it changes all the time. So there it wouldn't make sense to actually attempt to buy something and wait for 30 seconds, I guess, if you want to be very strict with the price.
Yeah, so that is at the program level, you would implement that. For sure
okay.
You can do that. For my one of the projects I'm a CTO for, I say they when I'm the one writing the code. Well, I'm using the Manifest order book, which is an open source one. And they have you can, when you're placing an order, you can be like, okay, I want the timeout at this, I want it to be this type of order and all that. But the basic SVM bare metal level It's just the 30 seconds. That's
Okay.
just what it's going to be. But if you want to change that, you can change it. You have to do it via your program.
Okay.
But yeah, back to these headers. They're basically just sanity checks. You can see down here, and it's just like, hey, do I have all the signatures that I need? Are all the accounts that are supposed to be writable, and have they signed, and yada, yada, yada. This is another thing that could cause it to fail. And then finally, you actually need to, everybody who is a signer needs to actually add a signature. And once you have all of these things, you can send it to the RPC, and hopefully it will execute.
We saw previously that we can have parallel transactions. How are they here?
That's
They're in the same state.
actually gonna be a little more explanation in the next session what we're gonna do. But I can point out that it's exactly the point where you can see why it's gonna happen. So what Jack just explained, the accounts. So that's a little different from other chains, I guess, because in Solana, when you're sending a transaction, you have to add all the accounts that you are gonna interact with. So every single account, and you have to say if it's a read-only account or if it's an account that you're gonna change. So if there are read-only accounts, like for example execution programs are the read-only accounts, you know. That means that the program can be present in multiple transactions next to each other because the data of the program not gonna change. The program gonna change the data in another account, and that account is gonna be writable. So that account not gonna pop up in any of the rest of the transactions that are running in parallel. And that's how the runtime
Kind
goes.
of blocked because it is trained.
Because you say that you're gonna change the data there, and you can only be the one that's gonna change the data.
One writes and the other just read. The account, there are some accounts that read and only one is the one that writes.
You can have multiple that write. Like for example, in this, even on just a simple program, simple transfer between Berg and I, both of our accounts need to be writable because if I'm sending him money, he needs to be able to write to my account and say minus whatever, and then to his account say plus the same amount.
They are not included in the many transaction list because it's writable.
That is gonna be only in one transaction. It can be in
That's like
transaction,
to
so
open a
it can
file
be.
in a computer and you edit the file, cannot edit by me also
Yes.
because it's edited by you.
Yes, exactly. So it's like if I am trying to write to my account, and then there's another transaction that also wants to write to my account, you can't both get that write block. Only one of us would be able to execute at the time. And that's like another interesting case where something could fail is like, say if I had my private key here and I have it on my laptop and I send like a transaction where it's like on here I want to, like basically two things where it's not possible. Like let's say I have 4 Sol in my wallet and then at the same time I try to send 4 Sol to W and 4 Sol to Berg. Whichever one lands first is going to execute, and then the other one's going to be like, well, you don't have 4 Sol anymore, so I can't.
When you take the read access to one account, so let's say I want to send some source to one account, does that mean that I can't read this account on any of the other 3 threads? Or like if I write my account and it's running on one thread, all the other transactions that are interacting with this account must be on the same thread, or can they also read operations on other threads?
If you have reads, you can read the same account on all of these different things. But if one of them is mutating it and then the other ones are trying to read it, then it's a little.
It could create conflicts. If
Yeah,
I write somewhere, maybe the scheduler will sometimes make the read on one other thread go before the write, maybe after. So it's not really, you have no guarantees of when it's occurring. So it should be all on the same thread. Once you try to write an account, I guess it's all on the same thread, but I'm not sure. So
Yeah, the thing is, you're gonna have to understand a little bit of the account of Solana to see how it's happening. So, for example, on Solana, every account is owned by a program. So even your wallet is owned by the system program. So, for example, if you want to send Sol to me, our account's gonna get locked for that operation, but the system program is of course just execution. So we can have the same transaction if he wants to send some SOL to him and you to me and Jack to W. We're gonna have the same. We can have those transactions running parallel. So only our accounts are writable and the system program is just executing this stuff. How can I say that the best? Yeah, so those accounts are getting, for that short time when actually it's getting processed, those accounts are getting locked, so it's impossible that anybody else get to that account while you are processing the transaction.
Probably there is a semaphore in SVM where you lock and unlock.
Yes, there.
Okay, cool.
So did we talk about all the things we're supposed to talk about?
Are we on it? I didn't know when we started.
How about lunch?
Yeah, it's
Lunch is at 1:30. Okay, so through a transaction from wallet connect to finality, we definitely do that. Client side.
I actually had a question about the pre-flight checks. So if you send it to a validator, your transaction that you want to do that, is it possible that the validator sees that info and tries to structure your transaction prematurely in a block and then run from you, or is that not really?
I mean, I guess there is a possibility, but the simulation is maybe some modified clients would do that, but the simulation is you actually ask the validator to, yes, this is my transaction, I want you to simulate it, and it's gonna be almost like real life executing the transaction. It's just not getting executed at the end. I mean, all the steps are getting checked one by one, but I don't think that the validator, no, it wouldn't work because you signed the transaction, so.
I have to do it.
Yeah,
I guess I was also spoof validators like, oh, I want to do this, and then like not do it. But then you already signed it, so it's
I have a question. What's the difference in a transaction when confirmed and finalized?
Say it again, please.
Confirmed transaction can status.
Yeah.
Confirmed and finalized. Which one is the last?
Finalized.
And what is different?
That all the validators agree that's a valid transaction. It's getting included in the block.
Okay.
To confirm is that the transaction is valid in the sense of that it's not wrong, so the form is okay and it's accepted that it could be processed. And finalized is actually when it is processed and it's agreed that is a valid transaction by most of the validators.
Okay. Alright.
So there is a difference in a little time difference, not much. Just to get to finalized it takes a little longer than getting the transaction just confirmed that it's okay. I get that could be a real transaction.
Cool. So yeah, looking at the schedule, what we're supposed to do now is just go through some code. So we'll go through first the most basic example, which is just a transfer. So what we can do.
Should we have a 5-minute break or something?
Sure. Yeah.
Yes, please.
That'll give me time to remember what this all says.
maybe some chances to get not so obviously.
Yeah, that's what I would.
This is probably for the patient.
No, this is for the free run.